All right, let's get into it. We're going to look at something you see on every golf course, a towel. But it turns out making one that actually works, one that cleans your club and doesn't fall off the cart, is a surprisingly deep engineering problem. So today, we're going to peel back the layers on the hidden engineering that separates a great golf towel from, well, a useless, soggy rag. So, first things first, why is it so darn hard to get a golf club truly clean? You know the feeling? You give it a quick wipe, it looks okay, but your next shot just feels off. Well, the answer is that not all dirt is the same. There are two very different kinds of grime we're dealing with here. And this is the critical distinction. On one side, you've got surface contamination. That's the easy stuff, a bit of mud, some moisture. But the real performance killer, that's the embedded contamination, the sand and soil that gets packed deep into the corners of your club's grooves. And that brings us to our first big idea. This isn't just about dirt. It's actually a problem of geometry. The very shape of the golf club is, in a way, designed to trap gunk. This is what we call the groove geometry trap. Think about it. A club's grooves are these perfect little canyons for dirt to hide in. It doesn't just sit there. It gets jammed into those sharp corners. And when you give it a quick wipe with a flat towel, you're pretty much just skimming right over the top, without applying any real force down where you need it most. And this picture just shows it perfectly. See how the flat parts of the face look clean, but the grooves are still caked with dirt. This is the difference between a club that looks clean and a club that performs clean. You've got a cosmetic wipe, but the parts that actually affect your shot are still totally contaminated. Okay, so we have a dirty club. Now let's talk about the tool we use to clean it. We've got to understand the actual science of the wipe, because a good towel is doing way more than just soaking up water. You see, a towel has two completely different jobs that people often mix up. Absorption is all about managing water. But to dig that embedded debris out of the geometry trap, you need friction, a real scrubbing, disruptive force. A towel can be amazing at soaking up water and still be absolutely terrible at cleaning. And this brings us to that incredibly frustrating moment every golfer has had. Why does the towel that worked perfectly on the first hole start just smearing dirt all over the place by the time you get to the back nine? Let's walk through how this failure actually happens. So at first, water loosens up the debris. That's good. That's what you want. But as the towel gets more and more soaked, its microfibers can literally collapse. And when they collapse, they lose their ability to trap and isolate that dirt. So instead, the grime just sits on the surface, and your towel basically becomes a paintbrush for mud. And yep, there's a technical term for this. It's called the saturation penalty. It's that exact moment the towel crosses a threshold. The weight of the water changes its physical properties, it loses its friction, and your cleaning tool officially becomes a smear tool. This helps us bust a really common myth. You know how we're always told a heavier towel, one with a higher GSM or grams per square meter, is always better? Well, that's just a measure of weight. What really matters is how that towel's fiber structure holds up when it's soaking wet. Does it fight against that saturation penalty, or does it just collapse and start smearing? Okay, so we've got the cleaning science down, but what about the other half of the puzzle for a magnetic towel? Actually keeping it attached to the cart. And again, the physics here is probably not what you'd expect. The real test for a magnet isn't in a store or a lab. It's right here, on a moving, vibrating, bouncing golf cart. A static pull test where you just yank on it tells you almost nothing about how that magnet is going to perform out on the course. That's because there are two totally different forces at play. Pull force is that straight-off strength you feel when you pull a magnet directly away from a piece of metal. But on a cart, the real enemy is shear force. That's the sideways sliding, peeling force that's constantly trying to knock it off. This is the key concept: shear dominance. All those little starts, stops, and bumps during a round of golf create thousands of tiny, repeated sideways loads. It's these lateral stresses that eventually cause the magnet to give up and fall off, not one single strong pull. So now let's tie this all together. The science of cleaning and the physics of attachment, these aren't separate problems. They are deeply connected parts of a single, elegant system. And this is what we call the performance chain reaction. The towel's weight affects how much water it holds, which affects how it handles debris, which affects how clean your grooves get, which, of course, affects your ball flight. And here's the kicker. The magnet's reliability affects how often you even bother to clean your club. You see, when you change one little thing, you end up changing everything. A really effective design understands all this. It treats the towel as a complete system. You can actually see it here.
There are distinct zones engineered for different jobs. You've got a tough scrubbing area for friction, a wet clean zone to break up the mud, and a dry finish area. It's not just a piece of cloth, it's a multi-tool.
So the big takeaway is this. When your towel starts to smear or your magnet falls off the cart, that isn't just random bad luck. It is a predictable outcome of specific design choices meeting real-world conditions. It really makes you wonder, what other simple products in our lives are actually these complex hidden systems?